Alright, so hi guys. So in this video, what we're gonna do is we are gonna go over trigonometric limits. Alright, the last video we did limits with square root functions and and also polynomial functions by indeterminate form and just kind of simplifying and using what we know about factoring and all that fun stuff. But now it's time to actually go a little bit further, and so in reality we want to know, and there's one very important thing that I do want to mention with trigonometric limits, because there's two very specific rules when it comes to trig limits. Now, this is not going to include squeeze theorem, because squeeze theorem is just something that I'm not really good at. I'm not really good at that, but I will do like limits as far as with just trigonometric functions in general. Now, let me see, give me 1 second. Okay, so yeah, so the reason why I didn't go over this in the last video is because I didn't want to make it way too long. But we are going to focus on trig limits in this video. Now, trigonometric limits, I will say it's not as, how do I say it? Like, it's not as, in depth. Like, it's not really as long as when we learned about, square root limits as well as polynomial limits. So let me look up. Give me a second, guys. I'm just looking up like some problems. So, okay. Let me just write down the two rules that I'm talking about. So rule number 1. This is rule number 1, and it says that the limit as x approaches 0 of, and I believe it's sine of x over x, and it's going to be equal to, I think it's 0 or 1. No, it's 1. This is equal to 1. So this is the first part of it. This is the first rule. Rule number 2 is the limit as x approaches 0 of, let's see, I'm looking for it. I'm thinking it was 1 minus cosine theta, or 1 minus cosine x. I can't remember exactly. Give me a second, guys. Okay, it's as x approaches 0 of 1 minus cosine x over x equals 0. So this is the other one. So we want to keep this in mind for this video, right? So give me 1 second, hold on. So this one says the limit as x approaches 0 of sine of 4x over x. Now, obviously, if we do direct substitution, we have sine of 4 times 0 over 0, which is going to be sine of 0 over 0, which is 0 over 0, which is, oh no, right? So what are we going to do exactly? Well, there's a rule, okay? There's a rule to this. If we have a limit as x approaches a value c of sine of a number a times x, over x, then that means we can say that this is equal to a times the limit as x approaches 0, or x approaches c. Well, actually, let me put 0 instead. So that way, so the limit, so a times the limit as x approaches 0 of sine of x over x, that would be equal to a times 1, which is just a. So basically we can say that the limit as x approaches 0 of sine of 4x over x is equal to 4 times the limit as x approaches 0 of sine of x over x, which is just 4 times, and all of this part, if you think about it, all of this, like we said earlier, is equal to 1. So we're just going to say 4 times 1, and that's just 4, okay? And that's how you do it. It's really not that complicated. You just have to remember the rules of sine of x over x and 1 minus cosine x over x. So this next one is a little weird, but let's go ahead and do it. The limit as x approaches 0 of secant x minus 1 divided by x. Now if we do secant x, that's just going to be 1 over cosine x minus 1 over x. And if we do direct substitution, we get 1 over cosine of 0 minus 1 over 0. And then we have 1, and then cosine of 0 is 1, so 1 over 1 minus 1 over 0. This is equal to 1 minus 1 over 0, which is just 0 over 0, which is, oh no, right? So, what are we going to do? Well, the way that we do this one is, so basically we can grab this, since we already simplified it into terms of cosine. We have 1 over cosine x over x minus 1 over x, basically. So what is this part here? What is this part? That's going to be 1 over cosine x times x over 1, which is really, or actually, hold on, no. It's going to be times 1 over x, excuse me, and then minus 1 over x. So then we have 1 over cosine x, or 1 over x cosine x minus 1 over x, right? And then, so basically, you do it again, and it still gives you, as the limit approaches 0, and it still gives you indeterminate form. So then what you have to do is, so, okay, so, this in reality is going to be, so let me try to do this, hold on. It would be, okay, so we're going to do cross multiplication. We have 1 times x, because remember a over b minus c over d equals ad minus bc over bd. So we're going to do that here. So you have 1 times x minus 1 times x cosine x over x times x cosine x. This is going to be x minus x cosine x over x squared cosine x. So you can actually simplify this. in reality. You can say that this is equal to x. So let me try to just explain this as best as I can, because this one's a little hard. So basically, let's see here. Give me 1 second, hold on. Okay, so then you're gonna factor out you're going to factor out an x, so you have x times 1 minus cosine x over, and then you're gonna say x times x cosine x. And this is gonna give you so that you're gonna cross this out, and then you're gonna get 1 over x, so it's gonna be, let's see here, hold on. So it's gonna be 1 over x cosine x minus the cosine x over x cosine x. Well, oh my goodness, this one's kind of hard. I'm not gonna lie. Give me 1 second. Hold on. Okay, so we're just gonna do it this way. If you think about it, this can be divided into two things. So we can say that, so if we have a minus b over cd, we can say that this is equal to a minus b over c times, and then 1 over d. Okay, I know, it's a little bit weird, but trust me, it works. That's basically what this is. So here we can say that this is equal to 1 minus cosine x over x times 1 over cosine x. And this is the limit as x approaches, and I believe it was 0, right? As x approaches 0 of 1 minus cosine x over x times 1 over cosine x. So this is equal to the limit as x approaches 0 of 1 minus cosine x, 1 minus cosine x over x times the limit as x approaches 0 of 1 over cosine x. And then we know right up here that we put the limit as x approaches 0 of 1 minus cosine x over x equals 0. So we have 0, this is equal to 0, and then times 1 over the cosine of 0, which is equal to 0 times 1 over 1, which is just 0. So the limit as x approaches 0 of, it was secant of x minus 1 all over x is equal to 0. Okay. That was an interesting one. It was definitely an interesting one. It was not one that I was expecting. Let me see, hold on. I'm trying to find one that's... I'm trying to find more that are with trigonometric limits, because I know there's more than we think. Hold on. Give me 1 second, guys. Okay, so this one is so interesting. This one's really interesting. It's the limit as x approaches negative pi over 4 of 1 plus the square root of 2 sine theta over the cosine of 2 theta. Okay? This one's interesting. Now, you have to be careful because, I mean, obviously, this is kind of why we, this is why, give me 1 second, guys. Okay, this is why we went ahead and did trig identities, because we need those for Cal 1 and 2, as well as Cal 3, believe it or not. So yes, we need to use trig identities for this. Now, obviously, if you plug it in, you're going to get something like, so it's going to be, and then over cosine of 2 times negative pi over 4. This is equal to 1 plus the square root of 2 times the negative square root 2 over 2. And then you have over, and then it would be cosine of negative pi over 2, because negative 2 pi over 4 is negative pi over 2. So you're going to get 1, and then the square root of 2 over 2, or the square root of 2 times negative square root of 2 over 2, that's negative 1, so it's minus 1, over cosine of negative pi over 2, that's just cosine of pi over 2, which is 0. So it's going to be 0 over 0, which is, oh no, right? Okay, so this one is interesting. We have to use trig identities to do this one. So the first thing that I want to make sure we understand is that the cosine of 2 theta equals cosine squared theta minus sine squared theta. And then if we solve it in terms of sine theta, we're going to get that the cosine, or this is really just 1. So if I color code it, so this is going to be 1 minus sine squared theta, and then we have minus sine squared theta, so then cosine of 2 theta equals 1 minus 2 sine squared theta. So then we can simplify this actually. This is equal to, and this part gives you a hint as to how to factor this. That's one of the factors. So yes, you have this factors as the following. So it's going to be 1 minus the square root of 2 sine theta times 1 plus the square root of 2 sine theta. So then you have 1, or actually, hold on. Oh, okay, yes, you have, so it's 1 plus square root of 2 sine theta, and then the bottom is going to be whatever this is. So basically, if I color code, this part is going to be this part here. So you have 1 minus square root of 2 sine theta times 1 plus square root of 2 sine theta. This cancels out, so then you have 1 over 1 minus square root of 2 sine theta, which is really 1 over 1 minus square root of 2, well, yeah, it's 1 over 1 minus square root of 2 sine theta. So then you're going to say the limit, you're going to do the limit as x approaches 0 of, or as x approaches negative pi over 4, excuse me, of 1 over 1 minus square root of 2 sine theta by direct substitution is going to be 1 over 1 minus square root of 2 sine of negative pi over 4, which is equal to 1 over 1 minus, and then you're going to do square root of 2 times, and it's going to be, so if it's negative pi over 4, that means it's going to be times the negative sine of pi over 4, which is negative square root of 2 over 2. So it's going to be times the negative square root of 2 over 2, because remember, sine of pi over 4, or sine of negative pi over 4 equals negative sine of pi over 4. Right, because remember that identity, sine of negative x equals negative sine of x. Okay. So we have 1 over, and it's going to be 1 minus, and in reality, so it's going to be square root of 2, negative the quantity, so hold on. Negative the quantity square root of 2 squared over 2. So then this is going to be 1 over 1 minus negative 2 over 2, which is equal to 1 over 1 minus negative 1, which is 1 over 1 plus 1, which is 1/2. So therefore, the limit as x approaches negative pi over 4 of 1 plus square root of 2 sine theta over cosine of 2 theta is equal to 1/2. Okay. Trying to see if there's any more. Hold on. Okay, so this next one we're gonna do, we have the limit as theta approaches, oh, and it says theta approaches negative pi over 4, my bad. I didn't read it right. This is the limit as theta approaches pi over 2 of tan squared theta times 1 minus sine theta. Okay, well, let's see. So, I'm just like really trying to think about this one because, okay, so we have tan squared of pi over 2. That doesn't exist. Huh. Let's see. That's an interesting one. So, oh my. Let me try to simplify this. So 1 over 1 minus sine, minus sine theta, times 1 minus sine theta, excuse me. So sine squared theta over cosine squared theta times 1 minus sine theta, so it's going to be sine of pi over 2 is 1. So basically if I do minus sine cubed of pi over 2, so sine squared of pi over 2 minus sine cubed of pi over 2 times the cosine squared of pi over 2 over the cosine squared of pi over 2. This is going to be 1 minus 1 times 0 over 0. This is going to be 1 minus 0 over 0, which is 1 over 0. So it does not exist. Oh wait, never mind. Yes, it does. Oh my goodness, hold on. This one's tricky. Okay, okay, I see. So let me see something, hold on. Wait a minute, guys, I messed up. I messed up on this one. I know what I did wrong. This is supposed to be... Okay, hold on, I got it. So it's sine squared theta over cosine squared theta minus... It's gonna be... Okay, hold on. Sine squared theta over cosine squared theta minus sine theta. Or no, sine cubed theta. Or rather, minus sine theta times sine squared theta over cosine squared theta. This one's, you have to be careful. Okay, so it's sine squared theta over cosine squared theta minus sine cubed theta over cosine squared theta. Now, by direct substitution, you have, so sine of pi over 2 is 1, cosine of pi over 2 is 0. Okay, so we have, I'm trying to see exactly how I can do this one. This one's tricky. The limit as x approaches pi over 2 of this, and trying to think. So I wonder if it's possible to... Hold on, give me 1 second, guys. I'm gonna try to see how this is. So let's see. Okay, so we can simplify this in the following way. We can say that this is equal to sine squared theta. So we have sine squared theta minus sine cubed theta all over cosine squared theta. This is equal to sine squared theta times 1 minus sine theta over cosine squared theta. Now, cosine squared theta is sine squared theta times 1 minus sine theta over, and then it's going to be 1 minus sine squared theta. This is equal to, and let me go ahead and just do it like this. This is equal to sine squared theta times 1 minus sine theta over 1 plus sine theta times 1 minus sine theta. cancel that out, and then you have that this is equal to sine, or was it sine squared theta? Give me 1 second. Hold on. Yes, this is equal to sine squared theta over 1 plus sine theta. And then you have, by direct substitution, you're going to do sine of pi over 2 quantity squared over 1 plus sine of pi over 2. This is equal to 1, so it's, I believe it's 1 squared over 1 plus 1, so it's 1 over 2. So, the limit as theta approaches, and I keep saying x, it's theta, as theta approaches pi over 2 of tan squared theta times 1 minus sine theta equals 1/2. Okay, this one was a little tricky, I'm not gonna lie. It was a little bit hard because, well, yeah, it was a little bit tricky. But anyways, guys, those were just a few of them. I mean, we can do, well, let's see, hold on. I mean, we can do a little bit more. I'm gonna just do, maybe, I'll do one more, or I'll do 2 more. So the limit as theta approaches 0 of 1 minus cosine theta over 2 sine squared theta. This is equal to, so obviously by direct substitution, it won't work. We're gonna get 0 over 0 by direct substitution, which is, oh no. So then what we're gonna do is we're gonna say that this is equal to the limit as theta approaches 0 of 1 minus cosine theta. And then the bottom part, we're gonna say this is equal to 2 times the quantity 1 minus cosine squared theta. Right, and then this is equal to the limit as theta approaches 0 of 1 minus cosine theta over, and then remember 1 minus cosine squared theta. So really, if you think about it, 1 minus u squared is equal to 1 plus u times 1 minus u. Similarly, like u squared minus 1 is equal to u plus 1 times u minus 1. It's like this, okay? So you're going to say 2 times 1 plus cosine theta times 1 minus cosine theta. And then you're going to cancel this out, so then you have 1 over 2 times 1 plus cosine theta. And the limit, this is equal to the limit. So this tells us that the limit as theta approaches 0 of 1 over 2 times 1 plus cosine theta is equal to 1 over 2 times 1 over 2 times 1 plus cosine of 0, which is equal to 1 over 2 times 1 plus 1, which is equal to 1 over 2 times 2, which is equal to 1/4. So the limit as theta approaches 0 of 1 minus cosine theta over 2 sine squared theta equals 1/4. Okay, one more, let's do one more, and that'll be it for this video. So the limit as x approaches pi over 2 of 3 cosine squared x over 2 minus 2 sine x. So we're going to do, this is 3 times 1 minus sine squared theta, or sine squared x, excuse me, over 2 times 1 minus sine x. So in reality, like I said before, 1 minus u squared equals 1 plus sine, or 1 plus u times 1 minus u. So then you have 1 minus sine x. So it's going to be 3 times 1 minus sine x times 1 plus sine x over 1 minus sine x. So then you're going to go ahead and cross this out, and you're going to get this is equal to the limit as x approaches pi over 2, right? Because it's pi over 2. Yes. Of 1, or of 3 times 1 plus sine x is equal to, by direct substitution, is going to be equal to 3 times 1 plus sine of pi over 2 and then you're going to say this is equal to 3 times 1 plus 1, because sine of pi over 2 is 1. So then you have 3 times 2, so it's 6. Or actually, hold on. Is it 6? Oh wait, oh, 3 halves. Oh, oops. 3 halves. It's 3. Okay. Alright guys, so that concludes this video. Trig limits are not, I would say they're very brief. I don't think that, they're, like, how do I say this? Like, I don't think they're extremely, how do I say it? Like, they're not that hard as long as you know the, your rules and everything like that. Okay guys, so in the next video, we are gonna get started with, so let me see, hold on. So in the next video, what we're gonna start to do now is we're gonna go on to derivatives, but, we're not gonna do rules of derivatives. We are gonna do finding the derivative by the definition of a derivative, by the limit definition. And the only thing about that one is that it takes a long time to do. I won't lie to you, it does. So please, I do think that in the next video it's gonna be a lot, but please, like I always say, try to keep up with me. If you have any questions, let me know. And if you have any questions about this, please let me know. But yeah, this is it for this video. I do believe we did as much as, I do believe I did a pretty good amount. But in the next video, we're gonna finally get into basically finding the the limits, or the derivatives using limit definition. So with that being said, guys, thank you so much for watching. Please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.